Okay, I want to go over the block diagram. So the block diagram is just simply a way that we easily show a flow process. And again, I'm going to start out with an example of block diagram. And this is food, your body. So we can just look at this. Food going into your mouth. And then we mix in some saliva. And then whatever you put in your mouth goes to where? Yes, your stomach. Mixed in with some acids from your stomach. Goes to your small intestines. Which is mixed with digestive enzymes, and then some of the product of your small intestines ends up sent to your blood, and though whatever gets from the blood ends up to the cells. And that's how we get food, the energy from the food into our systems. Well, we also have this other side mode here to the large intestines, where after the food travels through the small intestines, it goes to the large intestines, and then some of it, the energy or chemicals, some of the chemicals from the digested chemicals from the large intestines go to the blood, which ends up putting energy and chemicals into the cells. And then we have here waste, and we're not going to go into that details of that, but this is more or less a block diagram for your body. Food digestion, energy extraction from food. You are a flow process and you didn't even know it. But this is the block diagram where we're essentially illustrating each process of this whole entire flow as just blocks. And so it's an easy, simple way to visualize what's taking place in the flow process. These blocks have nothing to do with the actual shape, size, etc. of the various components here. Your mouth, your stomach, your small intestines, your blood, etc. It's just a simple schematic way to represent what's going on for a flow process. Let's go through another quick example where we have NH3 going through a vaporizer, which is going to a reactor where it's mixed with air. It's going to a boiler where we heat it up, and then we might send it to a cooler. Then we might send it to an adsorber that's mixed with air, and we end up here some product, HNO3, and so this was just a chemical process to take NH3 to produce HNO3. And again, simple block diagram, doesn't really show us what each individual component is, the functional, what the size, shape, or design is. It just simply shows us where chemicals are flowing. Now, if this is a real block diagram, I would probably indicate what each component of each stage is. So here's NH3, so this, after we go through the vaporizer, it's NH3. Well, after we mix NH3 and air, it reacts to form some HNO3 and probably a little leftover air and NH3, and then we heat it up and we have the same component. And I could, if this was a real diagram, what I would do is I'd go through and I would indicate what the composition of this stream is, composition this stream, composition this stream, this stream, this stream, this stream, etc. And then we'll have a complete idea of what's going on with this process. So the last thing that we want to cover are process flow diagrams. So everything that we've been working for so far in this little presentation have been block diagrams where everything is shown really simplistically. A process flow diagram, essentially what I'm showing you right here, is a much more detailed and schematic example or representation of a process. And in this case, what we're doing is we're showing equipment where it's at. So for instance, here we're trying to show you this equipment right here. We have some sort of mixer here, maybe. We might have a separator, a settler, salt bed, water wash, etc. We have here a little tiny valve. We have a heater. Here's our little pump. So we have a lot more bigger representation and more detailed representation of this particular flow process. Now, if you were in a chemical plant and you wanted to know where something is, this is the type of diagram you would want. You'd want to know, what's what, where it's at, and everything else. When you're just analyzing the mathematics, or you're analyzing the flow of the material, and you're trying to figure out the amount and so forth, block diagrams are perfect for this because they leave out a lot of the details that may be confusing or simply may not be necessary. So like the example from eating food, we don't need to know what the shape of the stomach is in order to better visualize or understand the whole process. Now, if I was a doctor and I was trying to understand how the details of the body work, sure, then I might want to know the shape and all the details of the stomach. So there are two different levels of how we can visualize different flow processes. We're going to deal 90% of the time, 95% of the time, we're going to deal with block diagrams. We're not going to deal with process flow diagrams very much. So you just need to be aware that the process flow diagrams exist, and you'll encounter them more as you get into the upper level chemical engineering classes. But you just need to be familiar with the two types of diagrams and what they represent and how to read them too. So there you go.